Hello friends, let's get started with 5G NR. Before going into details of 5G NR, let's first understand the few key differences between 4G and 5G. So as we all know, the data throughput is enhanced in 5G. That is the main point or main point of 5G. So for improving the data rates, the latency, ultra low latency is introduced in 5G. So here we can see 1 millisecond latency is there in 5G, whereas 10 to 50 millisecond latency was earlier there in 4G. The data rates is increased from 300 Mbps peak to 220 Gbps peak. Mobility support is also enhanced, like we can support vehicles going more than 500 km per hour also in 5G. Spectrum efficiency is enhanced by 3 times, 3x better spectrum efficiency is now there. Apart from there are few other differences in LTE and 5G new radio. You can have a screenshot for this slide and the next slides also, so that to get the further details and to remember all of these things. The talking about the releases, release 8 to release 14 was termed as LTE and LTE advanced. Release 15 onwards is called 5G. The frequency range is quite different as mentioned here. Services offered here in 4G are also offered in 5G. Apart from that, low latency application and massive IoT is also supported. Carrier bandwidth, as we all know, 20 megahertz is supported in 4G, but here in 5G below 6 gigahertz 100 megahertz is supported, and above 6 gigahertz 400 megahertz is also supported. Here also comes a concept of mm wave, that is millimeter wave, the range of which is 30 gigahertz to 300 gigahertz, which was not earlier present in 4G. The next major change is here we are having different kind of subcarrier spacing in 5G. Earlier we were having only one subcarrier spacing, that is 15 kilohertz spacing. Now we are having different type of spacings, 15, 30, 60, 120 and 240 kilohertz, depends upon your implementation. Radio frame length is same, 10 millisecond for both. Apart from this, you can have a screenshot and mug up all these points. There are few more differences in like here I have mentioned PBCH. Other channels are also having a different kind of structure. Channel structure is different, payload is different, CRC bits are different, placing of these bits are also different. So you can have all these in details. If you want, just ping me, I'll share those things. Few other network terminologies related to 5G you need to be aware before going towards the 5G architecture. So here we are having new RAN. New RAN is a radio access network which can support eUltra and new RAN, and can get interface to the next generation core network also. The BTS here is called G Node B, that is 5G BTS, and the 4G BTS support which will be supporting 5G network is called ELTE E Node B. Apart from this, there are four kinds of four or maybe more kind of implementation of architecture. Four of here is more prominent are listed here: non-standalone NR, standalone NR, non-standalone eUltra, standalone eUltra. So you can have this kind of implementation of architectures, like for non-standalone NR, G Node B needs LTE Node B as an anchor for control plane connectivity to 4G EPC. That means to communicate with 4G EPC on control plane, a G Node B requires LTE Node B. Similarly, for non-standalone eUTRA for control plane connectivity to next generation core network, the LTE node B requires G node B. Okay, and this standalone NR and this is standalone eUTRA. Standalone eUTRA is your typical 4G network deployment. Okay, and standalone NR is your typical 5G network. One interface is introduced here is called XN interface, which was earlier X2 interface. Like node B to node B interface was called X2 interface in 4G, and G node B to J node B here is called XN interface. Here we come towards the 5G architecture. So there are different kind of architecture in 5G. So let's get toward the lower diagram, the diagram which is in the lower side of the slide. So we just need to first understand what are the uses of this different boxes which are here in the architecture. So the first is AMF. So you know G node B, that is 5G node B, you know. The first to explain is AMF, access management mobility function. So as you can see, there are two connectivity to AMF, that is NG1 from UE to AMF and NG2 from G node B to AMF. So here we can see the UE can directly communicate to your AMF, that is access management function. Okay, so the control related information which was earlier NAS signaling you have seen in 4G. So UE was sending NAS to MME, but it was not sending directly, it was sending via node B. So this control type of informations were also shared through node B, but here it does not need to send information through G node B, it can directly communicate to AMF. So what are the main functions of AMF? So the first is the termination of RAN control plane interface, RAN control plane, and termination of NAS ciphering, access authentication, access authorization, security context management. So these are the access management and mobility function. Mobility is also included, mobility management is also included in your AMF. As the name is saying, access, that is authorization management, and mobility, that is mobility management. So for a beginner, you just need to learn, you just need to remember the access related and the mobility related functions are taken care by AMF. The second one is user plane function, that is UPF, connected to G node B. Okay, here it is UPF. The functions of UPF are QoS handling for user plane, quality of service handling for user plane. Packet routing and forwarding is also done here. Packet inspection and policy rule is also checked here. It is also anchor point for inter and intra-RAT mobility whenever it is applicable. So these are the main functions of, so you can remember as packet routing, forwarding, and inter-RAT and intra-RAT mobility whenever it is required. This is taken care by UPF, user plane function. The third is your session management function, or SMF. SMF supports for session management, as the name says. UE IP address allocation and management is also done here. Okay. The third one is data network. Data network is for to access operator services, internet access, or other services. We are using data network here. AUSF, that is authentication server function here. As the name suggests, it is used for performing authentication process with the UE. UDM, Unified Data Network, next to AUSF in this diagram, it's suppose the it is like a repository for authentication credentials. Okay, so the security credentials are stored here. Okay, subscription information is also stored here. So consider your UDM as a repository, as a store for all of these security functions and keys and subscription information. Everything is stored here. PCF like in we were having PCRF in 4G. So here it is PCF, policy control function. It provides the policy rules to control plane that enforce them. AF, application function, it was also there present when we were studying in the VoLTE structure. Application was there. So it requests the dynamic policy and charging control. So it is the basic understanding of your 5G architecture. The interfaces are here known as NG1, NG2, NG3, NG4. So this kind of interfaces are there, and G-Node B to G-Node B interface is called XN interface. So these are the basic. I can share you all the details if you want. Ping me one-to-one for this use of what are the uses of these blocks. Now we are coming towards the logical, transport and physical channel mapping. So as we all know, logical channels are from RLC to MAC layer, and MAC to physical layer are called transport channels, and these channels are called physical channels, physical layer channels. Okay, so uplink direction, downlink direction channels are almost the same as in used in 4G. So I don't think there is any need to explain. PCH is used for paging, BCCH for broadcast, CCH for control channel, DCCH for data, DTCH for also for data. The transport channel, PCH paging, BCH for broadcast, DLSCH for carrying your data, ULSCH for uplink data, RACH for random access. And for physical channels, you can see there are PSS, SSS, DMRS, PBCH. So these kind of things are also here. Few reference signals are introduced in 5G channels that we will be getting into details in further coming sessions if required. So that are clubbed with your physical channel in this diagram. Reference signals, DMRS, PTRS. So PTRS is introduced in your 5G. It was not earlier present in 4G. DMRS is present in 4G also. PUSCH you already know. PUCCH you already know. Okay, the physical channels you need to study for reference signals. SRS already know, sounding reference signal. So already know means it was already present in 4G. So if you want, I can make a separate video on these channels also. Just ping me. Here we are going towards the protocol stack. So I think it's enough for today. We'll be having a protocol stack related information in the next session. Thank you.